Hello everyone, welcome to Vectali. Today we are going to solve few problems from center of mass and collisions. These four set of problems will develop your intuition and will be somewhat beyond JEE advanced level. Let's go to the question number 1. A particle projected at an angle theta with the horizontal from the center of the floor of a cylindrical room of radius r returns to the point of projection after three elastic collisions with the wall and the ceiling. If the particle remains in air for time t, find the speed of projection. What happens is this we are going to project a particle over here, which is at an angle of theta. Okay. First collision will occur in this wall, and the second will be in the ceiling, and the third will be on the opposite side of this, and it will return to the same point of projection. So if I draw it, I would get this from the side view. So now what happens is throughout the side view, the horizontal displacement is this is r and this is r. So what happens is the particle starts here and it goes here, comes again to hit here, and then it comes here. So total distance is traveled at r. So displacement in x direction, sorry, total distance in x direction is nothing but 4r. If you see here, the only acceleration is caused due to gravity that is acting downwards. So throughout the motion in x directions, the speed would be the component of the velocity in x direction. So the speed, let me denote it with this velocity bv. Okay, so the speed in x direction, let me denote by velocity in x direction. This is the velocity vector and the magnitude is v. So which is nothing but v into cos theta. If you see, all the collisions are elastic. So if it hit this particular point with some velocity, anyway, this will only change the direction of horizontal component. This will change the direction of vertical component. And this will change the direction of horizontal component. But the magnitude will be same. So throughout the motion, the magnitude of velocity in x direction is v cos theta. And this x v cos theta is what used to travel 4r. Okay. Now all these distance, the overall distance 4r is traveled when the particle is in air. So total time t is nothing but v, sorry, s by sx by vx, because the total time t is take time taken by the particle to travel 4r distance in using v cos theta velocity. Okay, so from this we can get v is nothing but 4r by t cos theta. So option B is correct. Okay, now what about option C and D? Because it contains the term sine to theta, G and R. For this, we have to use a different kind of thinking, which is very much important. That is, if you see, if I remove this cylindrical room and project some particle with velocity v at an angle theta, its path would be somewhat like an projectile. Correct? Now, what happens if I place a wall over here? It will return. Okay. If I place a wall over here, it will return and it will go up till some extent. And let this point, if I turn overall this image, what would happen is it will go a bit of this extent till this extent. This point would be over here if I remove this wall. Correct? And again, this point would be something over there. But what happens is at this point, the velocity in y direction should be 0 if this is the topmost point. Correct? If this point is the topmost point of the this point corresponds to the topmost point of the projectile, the velocity at this point should be 0, but we don't know about it. Correct? So, if I what happens is we are cutting down this part in the projectile. That is, at this, if you see in a projectile, all the horizontal lines have the same. If you draw a horizontal line in this projectile, the point of intersection would have the same velocity. Correct? So, I'm assuming that if this is not the topmost point, there is some, these overall distance should be cancelled, because if I draw the projectile, this corresponds to part till this, okay, and this corresponds to the part this. So let me mark the parts 3 and 4. This is part 1, part 2, part 3, and part 4. And we can compress this distance r. This distance r may be 0 to some value. Okay, we don't know the exact height h. So we don't know the overall height h of the container. So we can't determine this exact value. So we can't equate it. So this should be a condition or an inequality. So suppose the total range of this projectile is, range is nothing but v square sine 2 theta by g. Correct? But this range of the constricted projectile, that is, it travels an horizontal distance of 4r, right? But we are constricting some part of it. So this range should be greater than 4r. Correct? So 4r is less than v square sine 2 theta by g. So what I get is v is greater than twice of under root rg by sine 2 theta. Question number 2. Three particle-like balls A, B, and C of mass m1, m2, and m3 are connected by identical elastic and almost inextensible threads. They are placed in a frictionless horizontal floor. The threads are straight and the angle between them is 60 degree. Initially, these threads are not in taut condition. The ball A is projected with velocity u equal to 6 meter per second parallel to the thread connecting the balls B and C. With what velocity will the ball C begin to move? First, what happens is we are giving the ball A with the velocity u. Of course, you will have a component in this direction which is perpendicular to this string AB. So this will develop a tension and ball B will be pulled toward this direction because of the centripetal force. Okay. And in that condition, also there will be a component of tension in this direction. So the string 2 will be in taut condition till this AB is getting stretched to the maximum level. Okay. What happens is this A will move till this extent. Okay. If in this condition, if this string is stretched, when it goes here, it will be in taut condition because the length will be comparatively less. And at this position, it will be at the minimum distance. And at which position the length would be maximum at the same angle theta over here. Correct? When the string AB makes angle theta with BC, the same length will be maintained. Correct? So at the same length, the string will be of the maximum extension, maximum length. Sorry. So this is that condition. At initial condition, at this particular time, instantaneously, the velocity of A would be u. Correct? So if we resolve into components, it will be u cos theta along the thread and u sin theta perpendicular to the string. You see, when this A and B are connected by the string, what happens is we are giving a velocity u cos theta along the thread. So it's like a collision. Since this is a thread, this is like a collision. So this thread will pull B. It's like A is going and hitting B. So what happens is finally after collision, what you get is A's velocity perpendicular to the string won't change. That is, u sine theta will remain the same, but the velocity along the string would change. So we don't know the value. We are assuming is as v1 and v2. And if we apply conservation of momentum along the string, what we get is, what is the initial momentum? M1 u cos theta, right? What is the final momentum? Final momentum is nothing but m1 v1 plus m2 v2. Actually, we have two variables over here, v1 and v2. We need another relation. So actually, the strings are elastic, right? So this obeys an elastic collision, okay, with coefficient of restitution e equal to 1. So what you get is velocity of separation v2 minus v1. This is, in this case, kind of threads case, what we will assume is body A, which is moving with the velocity u cos theta, is hitting the body B, which is at rest initially. So in that case, v2 minus v1 is nothing but the velocity of separation, which is equal to the velocity of approach. What is the velocity of approach? Which is u cos theta. So after solving, let this be the equation 1 and this be the equation 2. After solving these two equations, what we get is v2 is nothing but 2m1 u cos theta whole divided by m1 plus m2. Okay, so it's like a story in which first thread AB is experiencing of impulse when via which B is gaining some velocity. This is the first part of the story, part 1. And part 2, what happens is now B got some velocity, right? So B will pull C in this direction. So that is the part 2. Let's move to the part 2 of the story. And this is part 2 over here. Initially, the velocity of C is 0 and B is having a velocity v2. Okay. And this is v2 sine theta and v2 cos theta if you resolve it into components. Now, what happens is at that particular time, CB is horizontal. So, as we are finding the instantaneous time, so CB, the velocity of C will also be horizontal, which we are assuming v4. And the velocity v2 cos theta will change as v3 and v2 sine theta remains same. Correct? Similar to the case. So, if we use the conservation of momentum over here, what we get is m2 v2 cos theta is nothing but m2 v3 plus m3 v4. Correct? And again, v3 and v4 are variables, so we are going to apply e equal to 1. So what we get is the velocity of separation. Now, if you see, B is going and hitting C in this condition, right? We are assuming. So what we get is velocity of separation v4 minus v3 is nothing but velocity of approach v2 cos theta. Okay, and upon solving, what we get is v4 is nothing but 2m2 v2 cos theta whole divided by m2 plus m3. So this is the final answer. In v4 we are going to substitute v2 and we will get the final answer. Okay, now the very much important part of thinking intuitively in this question is, first, we have to analyze when the string AB would get stretched. Okay, that is at this position theta, which is logical. And second, we have to proceed this question in a kind of sequence. First, B will experience some impulse and then C will experience this impulse. We have separated into two parts, right? This is very much important in the problem solving procedure. Okay, and the main thing is the velocity of center of mass remains the same because there is no external force like gravity or something which is influencing this situation. That's it. Question number 3. Ends of three light identical rods, each of length L, are connected to a light pivot that enables them to rotate in any direction. At the other ends of the rods, three particles A, B, C of mass m, 2m, and 3m respectively are affixed. Initially, the rods are coplanar. Angle between any two adjacent rods is 120 degree and the particles are at rest. Now the particle C is given a velocity u perpendicular to the rod connected to it. In the plane of the rods as shown in the figure, ignore gravitational interaction between the particles. First, let me explain this scenario in which This is in a plane. Okay. uh, B, C, A are connected to this pivot, okay, which is very lightweight. We'll assume the mass to be 0 and let us mark the pivot as O. Okay. Now what happens is all are in a plane and we are ignoring the gravitational interactions between A, B, C. Okay. Now uh, C is given and velocity perpendicular to the rod. Okay. And all the remaining things are in rest. Okay, so from this situation, if we assume the ABC and the rods as a system, we get the force net on the system is nothing but 0. So acceleration of the center of mass of the system is also 0, which is nothing but m times acceleration of A plus m times acceleration of, sorry, 2m times the acceleration of B and 3m times the acceleration of C, whole divided by the total mass of the system, which is 6m. From this, we can conclude that acceleration of A plus twice the acceleration of B plus thrice the acceleration vector of C is 0. So this gives the solution for the first question, which is denoting acceleration vectors of the particles ABC by A vector A, A vector B, and A vector C respectively. Which of the following conclusions can you make? So this gives us option C is the correct answer. Let's go to the question number 2. What are moduli of accelerations vectors of the particles A, B, C immediately after the particle C is given velocity u? When particle C is given a velocity u, which is perpendicular to the rod, the only force acting, the only acceleration acting on C with respect to the center O is the centripetal acceleration. So, which is acceleration of C with respect to O is nothing but the u square by L. Okay, and A and B doesn't have any velocity in perpendicular to this pivot. So, acceleration of A with respect to the O is nothing but 0, as well as acceleration of B with respect to O is 0. Okay. And these are the centripetal accelerations of A and B with respect to O, which are 0. Now, if you see from the ground frame, what will happen is there will be a force tension which will be pulling this point towards this direction. What is the magnitude of this tension? We have to find it. The same tension T would be acting over here and here because all these angles are 120 degrees. So the components perpendicular to this OC would get cancelled if these two are 150. And along this direction, we will get the same T. So that the net force acting on O is 0. So what would happen is acceleration of A is nothing but T by M, and acceleration of B would be T by 2M. So it's just the magnitudes, not the vectors. And acceleration of C is same tension T by 3M. Okay, this is the magnitudes. Now we have to find the value of T in order to solve this question. So how are we going to do it? We have all these relations with respect to this point O. So let's assume the acceleration of point O to be ax I cap plus ay into j cap. So, and what happens is, let this be point A. Okay, this has an acceleration AA over here. What this angle is nothing but 30 degrees because it's 120. So it will, if you connect it 30 and 30. And what happens is similarly, this is AY and this is AX. So what you get is acceleration of A magnitude wise is nothing but AX cos 30 degrees. Cos 30 degrees plus AY sine, what do you get? AY sine 60 degrees. Sorry, sine 30 degrees. So AA is nothing but AX root 3 by 2 plus AY by 2. And acceleration of B is nothing but negative of the acceleration of Y in j cap direction. And we are speaking about the magnitudes, right? So acceleration of B is minus AY because both are connected by the rod. And if this goes AY in this direction, B will also go. And we are assuming AY to be a top, so it should go down because of the tension force acting on the B. Okay, now what we get is acceleration of C with respect to O. Okay, now what happens is the other relation. This is what the direction of the centripetal acceleration v squared by L. And the acceleration of C with respect to ground will also be in this direction because the tension force is also in this direction. So we have to align the component in this direction. So this whole thing, the whole acceleration is speaking about this direction. And if this is 90 and this would be 30 degrees, of course. So what we get is AX cos 30 degrees, which is acceleration of C, okay, equal to v squared by L plus acceleration of O along this direction. So which is AX cos 30 degrees, which is AX root 3 by 2. So here come we get minus sign, and then we get minus AY by 2 because we are taking the negative of AY and sine 30 degree of it. So, and this becomes the magnitude. It will not become a vector, and we are speaking about the magnitude of the acceleration AC. So what you get is AC plus AX into root 3 by 2. You get minus AY by 2 here, which can be written as plus AY by 2 minus AY. So which is V squared by L. Sorry, it is supposed to be V square or U square, both are same. Okay. So which can be written as AC plus AB is minus AY. So plus AB, and this whole part is nothing but AA. So plus AA, which is V square by L. And if you put T by 3M plus T by 2M plus T by M, which is V squared by L, we get tension T to be, if I take the LCM is nothing but 6M. And if I multiply 2 plus 3 plus 6, which is 11, equal to V squared by L. So from this, I can consider T is nothing but 6M V squared by 11L. And we can individually find AC, AB, and A by substituting these things. Okay, this is the question number 3. Question number 4. A hemispherical bowl is placed on a frictionless horizontal floor and a small disc is placed on top of the bowl as shown in the figure. So this is a hemispherical bowl which is placed upside down and a small disc is placed above. The disc and bowl are of equal mass and there is no friction between them. There is no friction between them, and let's suppose the mass of each of them Vm. Okay. Now the disc is slightly pushed horizontally so that it starts sliding down the ball with a negligible speed. So we are giving a negligible amount of impulse. So we get a negligible amount of speed with which this disc moves. Okay. At what angular displacement of the disc measured from a vertical line through the center of the ball will the disc lose contact with the ball? Let's draw this situation when at the point of leaving. So let's mark the angle theta with the vertical. Let's suppose this at this theta, this disk leaves leaves the contact with the hemispherical ball. Um, there will be no horizontal velocity difference at this particular point. Both will have the same horizontal velocity difference because both will be in contact. Okay, so one component would be V naught, which is the velocity of the hemispherical ball in the horizontal direction. The same velocity V naught will also be there in the disk. Also, the disk will move relative to this in the path which is arc shaped. Okay, so we get V which is perpendicular to the radius vector. Okay, so this would be perpendicular to the radius vector. Now, if you see exact velocity of the disk, it is V naught, and this is 90 degrees minus theta. Okay, if we mark angles, it will become 90 degrees minus theta, and we get V sine theta, which is downward, and V cos theta over here. Now, if you see, we consider this bowl and the disk as a system, the acceleration of the system, there is no external force in the system. So acceleration of the center of mass is only due to acceleration due to gravity g. Okay, and velocity of, let's, okay, velocity of the system, final velocity of system, sorry. Now let's consider the final momentum is nothing but the initial momentum. We apply the conservation of momentum because there is no external force acting in the system except gravity, that we have included it. Okay, so initial momentum is nothing but 0. So P initial is nothing but 0 because we are giving a negligible speed. So initial momentum is 0. And the final momentum is nothing but, there is a momentum in y direction which is caused due to this acceleration due to gravity g. Okay, now let's conserve the final momentum in x direction. So final momentum in x direction is, the mass m has velocity is v cos theta minus v naught plus, and this particular hemispherical bowl as component minus m v naught. Okay, so final momentum is also 0. So what we get is v cos theta minus 2m v naught. So what we get is v is nothing but 2 v naught by cos theta. So this is the first relation we are going to get. Okay, now what is the second relation? Okay, now let's use conservation of energy of the whole system. Okay, so the change in energy is nothing but the potential energy change observed when the disk moves from the topmost point to this particular point. So which is nothing but mgr into 1 minus cos theta. This is an usual result which you can do it as, and if this is r and this will be r cos theta, so the difference in height is nothing but r into 1 minus cos theta. So we get mgr into 1 minus cos theta as change in potential energy. Okay, now which is the reason for the kinetic energy. So half m, let's take the velocity v naught square, which is the kinetic energy of this ball, plus half m v dash square, which is the kinetic energy of this disk, where v dash is, let's write the v dash vector. So v dash vector is nothing but v cos theta minus v naught into I cap. Okay, plus v sin theta into minus j cap. So we can write this, let's cancel m on both sides. So rg into 1 minus cos theta is nothing but half v naught square plus v dash square is nothing but v cos theta minus v naught the whole square plus v square sine square theta. So 2rg into 1 minus cos theta is nothing but v naught square plus, if I expand this again, we get v naught square plus v square cos square theta minus 2v naught cos theta plus v square sine square theta. So what I get is 2rg into 1 minus cos theta is nothing but 2v naught square plus v square minus 2v naught cos theta. So here I get v cos theta is nothing but 2v naught. So again I get 2v naught square plus v square minus, so 2v naught the whole square, which is v square minus 2v naught square. Okay. Now they're asking 1 minus cos theta is nothing but v square minus 2v naught square. So if you see here properly, we don't know the values of v and v naught and r. So we have to eliminate these variables to get the exact value of theta because we assume these values. So we need one more relation. So what is that relation is? This is nothing but if I fix the frame with respect to the hemispherical bowl, this is undergoing a circular motion at with respect to this point, correct? So the centripetal acceleration, which is mv squared by L, which is nothing but mg into cos theta. So mg will be acting here. So mg will be acting here and this angle is theta. So mg cos theta is nothing but v squared by L. So v square is nothing but lg cos theta, which is rg cos theta here. So v square is nothing but rg cos theta over here. So rg can be written as v square by cos theta. So 2v square into 1 minus cos theta by cos theta is nothing but v square minus 2 into, we have the relation between v naught square and v square. So v naught square is nothing but v square into cos square theta by 4. V square into cos square theta by 4. So if I cancel v square on all the sides, what I get is 2 into 1 minus cos theta by cos theta is nothing but 1 minus cos square theta by 4. From this relation, what I get is, if I multiply, so 2 into 1 minus cos theta is nothing but cos theta into 4 minus cos square theta whole divided by 4. At last, you will get an equation which is a cubic equation of cos square cos theta. If you solve this, you will get cos theta. Okay, and from that we is if it is a cubic equation, we have three solutions, right? So in the three solutions, we have to find a solution such that the theta is between 0 to pi by 2. Okay, and cos theta should be greater than 0. So via this condition, we can filter the value of theta to get the one possible answer. So if you solve this particular equation, you will get the value of theta. Thank you for watching this video and do comment your doubts.